Imagine tiny robots zooming through the impossible-to-reach spaces, whether inside your body or in the tiniest industrial settings. Pretty cool, right? These micro-robots are pushing the limits of technology, designed to navigate the trickiest spots with ease. But there's a catch. To achieve full autonomy, they need power sources that are both super efficient and small enough to fit these microscopic wonders. So far, most have been solar-powered, but there's so much more on the horizon. Curious to see how? Keep watching to find out. Researchers have just upped the game with a mind-blowing innovation. A battery so small it's thinner than a human hair and can power robots the size of a period at the end of a sentence. Designed by MIT engineers, this microscopic battery opens the door for some seriously futuristic possibilities, like deploying cell-sized robots to deliver drugs inside the human body or even locating leaks in gas pipelines. Yep, that tiny. This new battery, measuring just 0.1 millimeters long and 0.002 millimeters thick, works by pulling oxygen from the air to oxidize zinc, generating a current powerful enough to create up to 1 volt. That may sound small, but it's just the right amount to power a mini circuit, sensor, or even a teeny tiny robotic arm. Imagine a robot no bigger than a cell, able to deliver insulin directly into a diabetic's cells with pinpoint accuracy. How cool is that? The idea of using cell-sized robots for drug delivery isn't exactly new, but finding a way to power them has been the real puzzle. Most of these little bots rely on solar power, which unfortunately needs either sunlight or a laser to keep them moving. The problem? Neither of those penetrates very far into the body, turning these marionette robots into, well, literal puppets. This new battery tech would cut the strings and give these micro-robots the autonomy they need to really go the distance. According to MIT's chemical engineer, Michael Strano, the current marionette systems don't need batteries since they all get their energy from external sources. But here's the catch. If we want these tiny robots to fully explore those hard-to-reach spots without being tied to the outside world, they need to be more independent. That's where a battery becomes a game changer. This new battery is one of the smallest ever created. To put it in perspective, back in 2022, researchers in Germany developed a millimeter-sized battery that fits on a microchip. Strano's team is taking things to the next level, creating a battery that's 10 times smaller, just 0.1 millimeters long and as thin as 0.002 millimeters. Imagine something the thickness of a human hair powering a robot. The secret to this battery's power lies in its two components, a zinc electrode and a platinum electrode, both embedded in a polymer called SU8. When the zinc reacts with oxygen from the air, electrons are released and flow to the platinum electrode, creating the energy needed to power the robot. Even cooler, the battery making process, called photolithography, is like something out of a sci-fi movie. It uses light-sensitive materials to print teeny tiny patterns onto silicon wafers, which is also how semiconductors are made. With this method, they can print 10,000 batteries on a single wafer. Talk about efficiency. This breakthrough was just published in the journal Science Robotics, and it's safe to say the future of mini-bot tech is looking bright. In their latest breakthrough, researchers took these incredibly tiny batteries and connected them to equally tiny cell-sized robots. We're talking robots no bigger than a human egg cell. Strano's lab, always at the cutting edge of innovation, decided to test just how much power these microscopic batteries could provide, and the result? Mind-blowing. First, they used the battery to power something called a MEM resistor circuit. A MEM resistor is a pretty cool little device because it can actually change its resistance band on the charge flowing through it. In other words, it can remember things by storing information about changes in charge. Imagine a tiny robot not only moving but also retaining a memory of what it's encountered. It's like a mini brain inside a cell-sized machine. But the team didn't stop there. Next, they used the batteries to power a clock circuit, which allowed these miniature robots to keep track of time. Think about the potential of this. Tiny robots that can tell time, crucial for any task that requires precise timing, such as medical treatments. And it gets even better. They also powered 2 super tiny nanosensors, one made from carbon nanotubes and the other made from molybdenum disulfide. These sensors are designed to detect leaks in places humans can't reach, like pipelines. So, in the not-too-distant future, we could have an array of tiny robots crawling through industrial pipelines, finding and fixing leaks before they become a major problem. Strano and his team are clearly thinking long-term. He mentioned that they're laying down the building blocks for cellular-level robotics, and he's not kidding. These tiny, dynamic robots are already showing what's possible, and we're just scratching the surface of their potential. For example, the team also used the batteries to power an arm on one of the cell-sized robots. Picture this: a robot so small, it's almost invisible, moving its arm thanks to this microscopic battery. It might sound like something out of a sci-fi movie, but it's happening now. And this tiny arm movement could pave the way for groundbreaking medical advances. Imagine robots that can navigate through your body, delivering drugs exactly when and where they're needed, without any external controls. These robots could revolutionize how we treat diseases, making treatments more effective and precise. What's even more exciting is where this technology is headed. Right now, these tiny batteries are connected to the robots by a wire, but Strano and his team are already thinking ahead. The goal is to ditch the wires altogether and build batteries directly into the robots themselves. This would make the robots completely autonomous, no external power source, no strings attached, literally. Strano is confident about the future, saying, "This is going to form the core of a lot of our robotic efforts." He even compares it to the way electric cars are designed around their batteries. Just like the battery is the heart of an electric vehicle, this hair-thin battery could be the heart of the next generation of micro-robots. The possibilities are endless, from medical applications to industrial problem solving, all thanks to these tiny, powerful innovations. These micro-robots are opening doors to a whole new world of possibilities, far beyond just delivering drugs. Imagine a robot so small it can sneak inside your body, not only diagnosing issues but also performing minimally invasive interventions. These tiny machines could collect tissue samples, clear blockages in blood vessels, or even provide real-time monitoring of your internal organs. It's like having a doctor on the inside, 24/7. The potential for continuous health monitoring is mind-blowing, especially when you think about sensors and transmitters being powered on such a minuscule scale. We're talking about advanced implantable medical devices that could keep track of your health around the clock without any bulky equipment. And it's not just healthcare that stands to benefit. The industrial sector is gearing up for some serious upgrades thanks to this tech. One of the most exciting applications: gas pipeline leak detections. These micro-robots, powered by their super tiny batteries, could crawl through miles of complex pipelines, detecting leaks with a level of precision and efficiency that's simply unmatched. No more guessing where a leak might be. These robots could pinpoint it exactly, saving time, money, and potentially preventing disasters. These micro-robots could also shine in industries where human access is either dangerous or downright impossible. Picture robots inspecting the integrity of a nuclear power plant without putting human lives at risk, or monitoring chemical reactions inside sealed reactors where humans can't go. They could even be used to explore narrow spaces and manufacturing equipment for maintenance, ensuring everything runs smoothly without the need for costly downtime. The possibilities are endless. It's only a matter of time before these tiny robots start making big waves in both medicine and industry. It's safe to say we're on the edge of a robotic revolution. MIT's micro-scale battery is powering us into a whole new world of possibilities, from cell-sized robots that could revolutionize medicine to cutting-edge innovations in industry. This breakthrough marks the dawn of a new era of nanotechnology. We're looking at a future where robots the size of cells will be powered by batteries as thin as a human hair, operating with a level of autonomy that was once the stuff of science fiction. And all this is just the beginning. As research keeps pushing forward, who knows what incredible advancements we'll see next. If you're just as fascinated by the future of robotics and nanotech as we are, smash that like button. And don't forget to subscribe and ring the bell to stay updated on all the latest tech breakthroughs. Got any cool ideas or predictions for the future of autonomous robots? Drop them in the comments below. We'd love to hear what you think. Stay tuned for more mind-blowing tech updates.